Want your stuff?
Can I borrow your?
Nope. I don't share.
Whatever. All right, ladies and gentlemen. Again.
Somebody finesse my progressions.
Guys, once again, we have a couple of quick things to go over. We should not have we shouldn't have to worry about too much material to start with. We will add 4 more proofs of what you did last night. We'll collect all that out tomorrow before we go on with the next ways of setting things. One of the things that I wanted to show you guys today, or actually probably 2, is that when we're talking about parallel, and one of the things that happens when we have parallel lines, you can be given parallel lines for any of your proofs. And when you have parallel lines, you have to come to the idea of, all right, that means one of those angle pair relationships occurs. For example, if given parallel, that means that we're going to look for one of the angle pairs. And the easiest thing to do is this. We write it this way. If 2 parallel lines cut by a transversal, remember that? We use that symbol instead of writing out all those words because all those words are annoying. Well, sorry. And we don't write it just without the arrows, because if we write it without the arrows, then all of a sudden it becomes a not equal sign, and that doesn't help us any. So we write out, if 2 parallel lines are cut by a transversal, then one of the 4 angle pairs occur. Then we have alternate interior angles congruent, alternate exterior angles congruent, corresponding angles congruent, or consecutive interior angles supplementary. Now, one of the things, or over the course of X amount of years and whatnot, of looking at what geometry textbooks generally show you guys as far as what type of problem to expect, more often than not, it's usually alternated interior or corresponding. Those are the 2 different angle pairs that show up from time to time with the specific text diagrams that we get. I rarely see consecutive interior and alternate exterior. It doesn't usually play doesn't really play nicely with, triangles, to be honest with you. So usually you're looking for one of those 2. So, bless you. Thanks. I would just quickly, maybe off the side, remind yourself of what they look like. Okay, just a quick little look of what they are. You guys have generally done a pretty decent job as far as knowing what angle pair is what, so that's not going to be a real difficult thing to come up with. What's weird is that when you actually see it within a proof, and that's what we want to look at today. I want to do an example of a proof with parallel. I want to do an example of a proof with an angle bisector, and maybe talk about a segment bisector as well. Okay? And that'll get you set up for what we're going to look at for this evening. Like I said, there's just 4 more proofs, and believe it or not, if you actually use your time wisely, I know, go figure, right? You'd probably be hard pressed not to finish out 75% of it. Okay. Not changing. Sorry, I'll give you a second. I don't need to get out ahead of you because I don't think we had this one written down yet, did we?
So what are the crazy arrows?
Which one do you have with you?
No, the crazy one. Yeah, the if. And then the Christmas tree.
This stands for if 2 parallel lines are cut by a transversal. All of that. It's a pretty much standardized symbol you see in most textbooks. I think you still see it in the 53, don't you? Did they talk about parallel in 353, or did they just go right to axioms? They did? Been too long. I don't know. Like I've told these guys, I don't remember it. Well, math class that took 15 years ago, I don't remember that. Wow! That's crazy!
So you were in math class in 2002?
You're SMRT. Old enough to know not to ask people how old they are. No, old enough. Thanks. Can I go to another one? We okay?
Yeah.
All right. So let's do an example. Let's say we have the following shape. Ladies and gentlemen, given yes, sir. One of the things that I have noticed over the past few days, as far as homeworks and things like that, as we're cutting through all of them, you guys have to make sure that you are labeling your letterings. What I mean is, a lot of times people just give me 3 letters. And 3 letters is what we need. We need to have symbols and stuff. Okay? In order for you to say that you've got triangles through it, you have to use a symbol that says, hey, triangle X, Y, Z. Not just A, B, C. I don't know what that stands for. You have to use the symbols for your letters, whether it's an angle or a triangle. Now, when it comes to segments, I'm not really worried about you putting that little bar over the top. That's not the end of the world. But you do have to make sure you keep when you have 3 letters, you have to make sure you have something in front of it. Okay? A lot of people aren't doing that. Yeah. So, what's always your first step in a proof? Given. Okay. Now, the other thing I want to make sure that you remember to do is that you really, 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 really need to draw pictures. Okay. I'm seeing a lot of that as well, where you're trying just to go off of the pictures you see in your textbook. It's very difficult to draw in your textbook because you have a computer. So what you need to make sure you do is actually draw the picture itself, so that way you can visualize it better. You can mark the diagrams better, so you can see what parts match up with what. Okay. Geometry is one of those few subjects that is so unbelievably visual that you're hard pressed not to do it. You're just doing yourself a disservice. Giving yourself sounds fun. Thanks, Joe. So we start with our given. AB, congruent, CD. What should I do to my diagram? Add the tick marks. Good. Mark it. Anything else I can say about those 2 segments? Nope. Well, yes. I go to my next given and I say that they're parallel. What do you mean? Oh, yeah, when I go to market, I usually make that little fancy. The arrows show that things that are parallel. So now, once you're getting this whole idea of being parallel, that's when you want to start looking at the diagram better. See where you can find that you have a transversal. And one of the things you'll notice a lot is if you draw it out, it makes a Z. And a lot of times what happens here for alternate interior angles, it's usually it's usually the angles that make the turn. The angles that make the turn are the ones that are going to wind up being congruent to each other because these create alternate interior angles. Okay? So when you go through these things, that's one of the things to look for. Diagrams that have a Z in it, whether it's a normal Z or a backwards Z. That's usually a dead giveaway that you have the following. We can say that now angle ABD is congruent to angle CDB. And this is where it's weird to write out. The reason that those two angles aren't congruent is because if two parallel lines are cut by a transversal, then alternate interior angles are congruent. It's the one time that you have to write out more than segment bisector or definition midpoint. Okay? You actually have to write down why. This is the one case when you have parallel lines that it takes a couple extra steps to write out. It's not that it's a very difficult thing. It's just that it takes a couple extra words to do so. Okay? Excuse me. So, remembering that there's no ass in math, we have a side and an angle, which means what's the next thing I need to find? Another side. What's the side that I have? The shared side. That shared side is BD. Why is BD congruent to itself? Yep. Yep. And that's fine. I mean, normally what I do, John, is I usually go through every one of my given statements first. That way I don't forget one of them. Because I know a lot of times when students will do, they'll recognize, oh, I got to reflect something. They'll throw it in, and they'll forget that they had another given, and they'll go, I don't know what's, because they forget about it. Exactly. Okay. Now do I now have triangles that are congruent? Yes. How? Or I should say why? Because the side angle is not good.
I'll give earlier.
That's fine. Merry Christmas.
Happy Christmas. No, I didn't.
Now, guys, again, you don't have to say that everything's congruent to each other there, Joe. What we're trying to do is get to side, 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 or side, angle, side. Do you have all three sides congruent to each other, or do you have two sides and an angle in between them? That's what you're looking for. And each of these problems, as we go along, kind of forces you into one or the other ways. And you won't know which way you have until you start marking diagrams and writing things out. The more you write your diagrams, the more you fill in the blanks, the easier all of this becomes. Because this blue sheet, or your what do you call it, progression sheet, this is your best friend for all of this. Because it tells you everything to do. A lot of times the only thing you have to do is come up with the missing part, like perplex it or something. Okay? Go on another one. Squint to looks fine.
It's a kite.
Guys. So we have not done an angle bisector yet. Let's look at them. I know we have angle bisector on our sheet. I think it's the second one we did. I apologize for the drawings. I'm really not good at drawing these diagrams. I try, but you know. So, as you start going through these types of problems, what you're looking for is what's an easy thing to write out, and then what has an actual definition. In this case, the only thing that has an actual definition is going to wind up being my angle bisector. So on your progression sheet, what does an angle bisector do? Angles are parallel?
Angles are
Yeah, it creates 2 right angles. Very good. All right. So as we start looking at this stuff, you have to remember that when you're talking about things in terms of geometry, a lot of the geometry stuff has, if it's a term, it probably has a working definition, which means that there's something I can do with that word, bisector, angle bisector. There's something I can do with that. So we start our proofs. We're a WX, figure it to YX. What should I do to my diagram? Perfect, yeah, add the tick marks. Okay. I add my tick marks right away. Now I go to my next given. My next given tells me that the one segment bisects the angle. Okay. Which means go to your diagram. What are the 2 now congruent angles that are formed? This guy bisects that whole angle. Do you have, does it say anything about down here? No. Does it say it is? Can you say it? No. You can't just automatically assume out on stuff. You can't just do stuff like that. Now, what happens here is, excuse me, that thing is so gross.
Yeah, I know.
You're wearing that sweatshirt. Just got scabies on her sweatshirt. Go. What are the 2 angles? WXZ, YX. Those are the only 2 that you can say. I don't know anything about down here. It doesn't say anything about it. A lot of times when you have these things, you can't just automatically assume something happens. Because once again, when you assume, you make a what? U and E. Is there any ass in math? No. There's no ass in math. You can't assume. And the reason, we're going to run sheet, we have angle congruent to angle, reason, definition, angle bisector. Because that's what it told me to do.
I understand.
Good. What's left? The middle thingy. What's the middle thingy? The shared side. So what do we use? Reflexive.
Side angle side.
Yeah, WXZ. Oh, I'm sorry. That was fine. Someone said side angle side. I just wrote it down. So this was reflexive property. I'm sorry. Sorry about that. So it happens all the time. Because it will say something and you write it down, like, oh, wait, what? Okay. And that's where you get that. Okay. Now, way back when we defined what was called a bisector. A bisector could be anything that cuts an angle into two parts. It can be anything that cuts a segment into two parts. For example, if you have a segment bisector, it could be a point that's a segment bisector, it could be two segments that are segment bisectors, a line could cut into a segment bisector, and so on. So what happens here is that if you're ever given that you have a segment bisector, you're basically do all the exact same steps as you would an angle bisector. But instead of saying that you have angles congruent, what do you have? You have segments, and instead of saying definition of an angle bisector, you would say definition of a segment bisector. And that's one of those weird things that happens from time to time with these things. So if given again, if you're given what's called a segment bisector creates two congruent segments. A segment bisector creates two congruent segments. So if I have a AB bisects CD. If AB bisects CD, what are the two segments that are created? I just put it there. If AB bisects CD, CE and it's what I'm getting at here, guys. It's the exact same scenario as if you had a midpoint. It's the same scenario if you have an angle bisector. You're using that definition to create the very next step. When we get into the proof stuff that we have this evening, I'm going to tell you that you'll see a segment bisector. You're going to see a parallel line. You're going to see angle bisector. You're also going to see perpendicular. Well, you have all of that information there. There's really very few things that you have to come up with on your own. So, I want you to do these. Oh, sorry, we're not done? Sorry. I want you guys to do the next, there's four more segments wants to look at. There are four more segments a triangle wants to look at. Can I let me know when you guys are good? I want you to do these four. I want to say it's page 232, I want to say. 28, 31. That was the next thing. Just add these four to the ones you had from last night. All right? But those are the four. When you're looking at it, I want to show you something real fast. If you look at 31, you're given that you have perpendicular twice. Well, you think about it in terms of your progression sheet. On your progression sheet, if you have a perpendicular, well, you would have, if you have perpendicular, then you have right angles congruent. That's 3 steps. Well, you got to do that twice. So there's 6 steps right away off of givens. Then you have another given about segments. Then you have a midpoint, which has a definition. So right away, just from the given statements on number 31, there's 9 things that you're going to write out. But none of them you have to come up with on your own. Everything is on your sheet. You just have to figure out the right letters. All right, so when you start getting into these things, some of them do take a couple extra minutes to write out, but that's why we use the progression sheets. That's why we keep everything in front of us. We don't forget about it. Okay? Go ahead and get started on this. Always give you guys a little extra time, meander about and see what's going on.